Throughout the chapter, we've been solving systems of equations, and we've normally just had two variables with two equations. Well, now we're going to up it to three variables, and really these processes or ideas can be used if you had more variables. But for right now, what we want is the same amount of variables as we have equations. And so here's what we're going to do. We have the three variables with three equations, and we're going to plan on really kind of to start with knocking it down to two variables with two equations. The way that we can do that is we're going to do something twice. We're going to take two pairs of equations and use addition or substitution method to eliminate the same variable in each pair. So step one really involves two things, and we want to eliminate a variable either by using substitution or addition, or we've been calling this elimination. Once we do that, we're going to take those two things from the first step and we're going to solve those like we've solved already in past lessons. And then once we find two of the variables, we can take those two variables, plug them back into one of the original equations, and find the third. So we'll make more sense of that as we work through this. So we have three equations with three variables. We have an x, a y, and a z in each of them. And so we're going to group two pairs, and we're going to use addition or substitution. Now, in this case, I usually prefer addition or elimination to do this. You can do substitution, and this one would work. You could like solve for x and plug it in here, but I really prefer elimination over the substitution. So what we'll do is we can actually take these two equations right here, and we can easily eliminate the y. So we'll have x plus y minus 2z equals -9, and then 3x minus y plus z equals 13. And we'll go ahead and eliminate the y's there. We can add these together. We have 4x. The y's become 0. Minus z equals -9 and 13 is 4. So that was one of our pairs. Our other pair, we're going to take these two, because these, again, can easily eliminate the y's. We have to eliminate the same variable in both times. So we eliminated the y here. So the next time we also need to eliminate y. So we're going to do 3x minus y plus z equals 13, and 2x plus y plus 4z equals 17. And once again, these did set up nicely for eliminating. Sometimes you might have to multiply both equations by something to eliminate, but these worked out well. So this is 5x. This becomes 0 plus 5z equals 30. And while I'm working with this one, hopefully you realize there's a 5 in all these, so we can divide each term, or both sides by 5, which is the same as dividing each term by 5, and we get x plus z equals 6. So that was step one up here. That was our step one. Group two pairs of equations and use elimination or substitution method to eliminate the same variable in each pair. So we eliminated y in both of those things. Now pair the results of step one. So this is a result here and this is another result, and use addition or substitution to solve that. So we'll go ahead and take those two equations. So we have 4x minus z equals 4, and we have x plus z is equal to 6. Well, this one works out nicely again. The z's are opposites, so we can go ahead and use addition method. Again, it might not always turn out this simple. You might have to multiply the equations by something, but this works out nicely. We have, by adding, we have 5x. The z's eliminate, equals 10. Dividing both sides by 5, we get x is equal to 2. Now we can easily find z. Let's go ahead and plug that back into this equation. So once you find one of them, just plug it back into one of these two, and you get 2 plus z equals 6. Hopefully you realize I'm using the second one. 2 plus z equals 6 because I'm plugging 2 in for x. Subtracting 2 from both sides, we get 4. Now we're still not finished. What we need to do now is take our x equals 2 and z equals 4 and plug those two back into any one of these originals. I'll go ahead and plug it in the third one. So we have 2 times x, which was 2. So I'm using this one right here. 2 times x, we found x was 2, plus y, that's what we're trying to solve for, plus 4 times z, which z was 4, equals 17. Well, this is 4 plus y plus 16 equals 17. 4 and 16 is 20, so we're going to subtract 20 from both sides, and we get y is equal to -3. And when we write our answer, we want to put it as an ordered triple, not an ordered pair, but an ordered triple. Make sure you put it in the correct order. X comes first, so 2, -3, and 4. And so that's our solution. Realize that solution, if you plug 2, -3, and 4 in for x, y, and z in each of these equations, it will make all three of them work out. And it's the only point that will do that. Okay, this next one, where we have 3 equations and 3 variables, but not each variable is in each equation. These kind of look harder at first. They really turn out to be possibly less steps. So our goal is to really get it down to eliminating the same variable in each. We really want 2 equations with 2 variables. So it's not really clear on these steps right here. But we want 2 equations with 2 variables. So this last one has an x and a z. The second to last has a y and a z. And what I'm going to do is I'm going to use this equation to help me get this to just have a y and a z. So I'm going to use substitution to start with, and I'm doing that because this is pretty easy to solve for. To solve for x, I could to solve for y, because I'm going to plug in for this y, I can subtract x from both sides, and I would get y equals 6 minus x. And so now what I'm going to do is I'm going to take that 6 minus x and put it in here for this y, and I'll have an equation that just has an x and a z, and down here I'll have an equation that's an x and a z. So I'm starting off with using substitution to try to get 2 equations with the same 2 variables. So what we'll do is we'll have 3. Instead of putting y, we're going to put 6 minus x minus 2z equals -10. Simplifying this, we distribute, we get 18 minus 3x minus 2z equals the -10 still, and we'll subtract 18 from both sides, and we'll get -3x minus 2z. -10 minus 18 is -28. Now that we've done that, we have 2 equations that have an x and a z in it. And so we're going to use those 2 equations. Now I'm noticing in both of our examples here we got rid of y. You don't always have to get rid of y, it's just what turned out for both of these. And now we have 2 equations with 2 variables we want to solve. This one doesn't work out as nicely, so let's go ahead and multiply. Let's eliminate the z's. So we'll multiply the top by 2, and the bottom we'll multiply by 5. So we'll multiply the whole thing here by 2, and the whole thing by 5. That will give us an 8x plus 10z equals 112. That's the 2 being multiplied by each term. Now we're going to multiply 5 by each term on the bottom. We get -15x minus 10z equals -140. And now we can eliminate. We get -7, -7x. The z's eliminate, equals negative 28. When we combine these, we get negative 28. Dividing both sides by negative 70, x equals 4. Now we're going to come back through. We can plug in this into one of our original equations. Let's plug it in this one. So we have 4 times x. Well, x was 4, so 4 times 4 plus 5z equals 56. This is a 16, so we'll subtract 16 from both sides, which gives us 5z equals 40. And then dividing both sides by 5, you get z is equal to 8. And now, with this, the way this one's set up, these all have just two variables. So we could plug x or z into any of the ones that have into either of these two to find y. This one looks easiest. In fact, this one's even easier. We can just do y is equal to 6 minus x. 6 minus x, x was 4, so y equals 2. And so we have x is 4, z is 8, y is 2. We put our answer as an ordered triple, so make sure you put your x first, then the y, and then the z. And plugging those back in, they should make each of those true. And that's your solution for that system of equations with 3 variables.